Hey guys, let's learn something very beautiful today as we move together and look at everything about your melting and boiling points. Oh yes, so your melting and boiling point is one fundamental and cardinal area expected of us to know. And the quick question is, what should we know about melting and boiling point? Let's start very fast with our lesson 1. So while we progress together, I'd like you to note this very fast and pay attention to these 5 powerful things we are going to learn. The first thing is all about what is melting. So we're going to look at what is melting and look at some cardinal things under that. They will go into what is boiling. After that, we look at what is called your heating curve. Very important. And then we look at your cooling curve. Then we cap it up with your past questions. Yeah, let's go together. Are you excited? Yeah, follow me as we move. So what is melting? That's the quick question. So when we talk about melting, first and foremost, you should know, reason it first before we define it. Melt, for something to melt, meaning it is transitioning from solid all the way to liquid. So let's say this guy here is your solid. Of course, this is your gas, this is your liquid. If you are moving from solids all the way to your liquid state, what is that called? It's called melting. That's why simply put, we say melting is the change of state, right? From solid to liquid. So that change of state from a solid to a liquid state, what is it called? It's called melting. And very importantly, this process occurs when a solid is what? Heated. In other words, if you are heating a solid, it means you are increasing temperature in that solid, right? So when I increase temperature in the solid, what will it result to? It will cause the particles to gain or acquire kinetic energy. Because I am increasing temperature, is that like, for example, when I take your normal ice block, you remove it from the fridge and you leave it down. What's happening? There is an increase in temperature. It's because they decrease temperature. That's why with liquid, we move from liquid into what? Solid. But for you to move from your solid to liquid, there must be an increase in temperature. Are you with me? So that increase in temperature we always result to an increase in kinetic energy. So if I increase temperature, what am I increasing? I am increasing what? Kinetic energy. And because kinetic energy has been increased, what happened? The particles of that solid that are now becoming your liquid, they begin to move faster and further. And when they move faster and further apart from each other, what happened? Bam, a liquid is born. Now, for liquid to be formed, what happened? Now, the solid there, is it gaining temperature? Is there an increase in temperature? There is decrease in temperature. There is an increase in what? Temperature. So that increased temperature will result to an increase in kinetic energy. And because there is increase in kinetic energy, the molecules that holds the solids together begin to move apart. As they start to move further apart from each other, what happens? It starts to what? Come down from solid to what? Liquid. And that process is called your melting. Very interestingly, I like you to note this, that when particles have gained enough energy to overcome the forces of attraction between them, what happened? The solid will turn into what? Liquid. In other words, they need enough energy, right? Now, this guy here is your solid. For solid to become liquid, it needs enough what? Energy to overcome the force that is holding it together. And very interestingly, you must note this, that the temperature at which your solid turns to liquid, that temperature is called your what? Your melting point. That's how we say melting point is the temperature at which this happens. What is happening there? The solid is turning into what? Liquid. That temperature is called your what? Your melting what point. I like you to note this very, very interestingly well. There is what we call the normal melting point of a solid. Oh yes. So what we refer to as the normal melting point of a solid. You know, this is one area they don't play with. Please understand this very quickly. When we say normal melting point of a solid, what do we refer to? First, you must note this, that the normal melting point of a solid is the temperature at which your solid transforms into a liquid under a pressure of 1 atmosphere. And 1 atmosphere there is what? 1 atm. So if they ask you, what is the normal melting point of a solid? Normal melting point of a solid is that temperature at which solid transforms or transition into liquid under a pressure of what? 1 atmosphere. If you get this very quickly with me, please, I'd like you to note this. There is what is called your what? Boiling. Very important. So what is boiling? This is the second part. I've looked at melting. You know that already. Now what is your what? Your boiling. Of course, you know, boiling, what comes into a lot of people's mind is when you carry your water, put it on top of like your cooker, and then it begins to heat, and then after that, you know, boiling just takes place. But please, there is more to it. I like you to note this fast, that boiling is the change of state. So melting is a change of state. Boiling is also a change of state. So boiling is the change of state from liquid to gas. So just imagine it now. You have to carry your normal water and put it on top of your or on top of your cooker, and then you begin to heat it, right? For it to move from liquid to gas. That's when boiling occurs. So the change of state from liquid to gas, what is it called? It's called your boiling. But more interestingly is that you must note this, that process occurs when the liquid is heated, right? And as the liquid is heated, that means there is an increase in what? Temperature. So an increase in temperature, what will it cause? It will make the particles of the liquid to gain kinetic energy. So increase in temperature will result to an increase in your what? Your kinetic energy. And because there is increase in kinetic energy for the particles, what happens? Those particles will begin to move faster and further apart. And because they are moving faster and further apart, of course, boiling is going to what? Occur. I'd like you to note this, that when the particles that are moving further apart from each other, when they acquire enough energy to break the forces of attraction that is holding the liquid together, what happens? It's no longer liquid. When that forces of attraction that is holding the liquid together has been broken, what happens? They begin to escape as what? Gas. And as they escape as gas, what happens? Before you know what is happening, boiling starts to what? Occur. So first and foremost, all you need to do is carry your liquid and begin to what? Increase your temperature. An increase in temperature will result to an increase in your what? Your kinetic what? Energy. Because there is increase in kinetic energy, motion will now start to occur. The particles of the liquid will begin to move faster and further apart. And when that occurs, the force or the forces that are holding the liquid together is no longer there because you have broken it. When you break it, what happens? Gas start to what? Escape. And before you know what is happening, boiling start to what? Occur. I'd like you to know this very fast. The temperature at which your liquid boils, what is it called? That temperature is called what? Boiling point. So what's boiling point? The temperature at which liquid boils is your what? Your boiling point. And also, you must note this, that when a gas is cooled, it's possible that you are not heating a liquid now to get gas. You know, we have your solid, right, to your liquid, from your liquid all the way to your what? Your gas. When you increase temperature in solid, what will happen? It will move from solid to acquire kinetic energy and leave solid and become what? Liquid. When you increase temperature in your liquid, it will leave liquid and become what? Gas. When you take your gas now and you decrease the temperature of gas, you decrease temperature, will it acquire kinetic energy or it will lose kinetic? It will lose kinetic energy, right? So when they lose kinetic energy, what happens? The particles of that gas, they now begin to move closer together. As they move closer together, are they going to be moving fast or slow? And because they are now moving slower, what happens? The liquid will be better at the end of the day. You see, eventually, the forces of attraction will hold them together. And when the force of attraction hold them together, what happens? A liquid is formed. And that process is called your what? Your condensation. So it's more like a continuous chain or process from one phase to the what? Other phase. Are you getting it now? As we move, I'm going to show you what is called your phase change. And you are going to look at all of these things and understand them in details. But please understand this, that if the liquid is further cooled, you see, you move from solid originally to your liquid, from your liquid to your what? Your gas. And then you move from gas back to what? Liquid. That liquid that you have moved to, when you cool it further, what happens? Will it acquire kinetic energy, or there is loss of kinetic energy, further loss of kinetic energy? And because there is further loss of kinetic energy, the particles will begin to even bind more together. As they bind more together, you will eventually move all the way from liquid back to your what? Your solid. Are you seeing it now? So if that liquid is further cooled, what happens? Its particles will continue to lose energy, kinetic energy. They begin to lose it, and they move even closer together, eventually becoming what? Tightly bonded one to another, and then solid is bettered. And when solid is formed, what do you call that temperature? Is it freezing now, or you call it boiling? Of course, that's freezing. If you move from liquid to solid, what happened? That's what? Freezing. Get ready. I'll teach you phase change very well, and then you are going to see all of these things with your 2 eyes. Are you with me? But please understand this. There is what is called the normal boiling point of a liquid. Constant exam question. What did I call it? Normal boiling point of a what? Of a liquid. So how do we define the normal boiling point of a liquid? Simple. Tell us this. That the normal boiling point of a liquid is the temperature at which its vapor pressure equals atmospheric pressure. Follow me. When is it that your boiling occur? When you carry your water and you put it on top of your gas. Let me say, for example, you are using gas to boil your water. As you put your water on top of your gas or your cooker, whatever you like, put it on top. What happens? Or stove, or even your stone in the village, and then you use pot and put your water on top of it. What happens? What happens is that as it continually acquire, there is an increase in temperature continuously, which will result to an increase in kinetic energy. What happens? It gets to a point where vapor pressure. I know you are asking me, sir, what is vapor pressure? You see, this, for example, is what represents your pots. As you begin to heat the water that is inside this pot, what happens? Pressure inside is rising. That pressure is called what? Vapor pressure. When vapor pressure equals the pressure of the atmosphere, and that pressure of the atmosphere is called atmospheric pressure. When the two of them, they are now equal, what happens? Or they are in equilibrium, boiling begins to occur. And that's what we call the normal boiling point of a liquid. What is normal boiling point of a liquid? It is the temperature at which vapor pressure, Vp, equals to what? Atmospheric pressure. Again, for the last time, what is normal boiling point of a liquid? It is the temperature at which your vapor pressure equals to what? Atmospheric what? Pressure. That temperature is called your what? Your normal boiling point of a liquid. And I'd like you to note this very quickly, that in simple terms, when the liquid gets hot enough, what happens? The molecules start to escape, right? And then they will form what? Vapor. At the same rate, the air above it pushes the vapor molecule back into the liquid. Now, you see, as vapor pressure is increasing, what happens? That vapor wants to escape, right? The air that is in the surrounding is pushing the vapor back into the container. In other words, there is more like a struggle at that initial stage. That struggle that we are encountering, that's where boiling starts to kickstart. Are you getting me now? So for a simple literal terms, what is boiling point? Your normal boiling point of a liquid, it is the temperature at which vapor pressure equals your what? Your atmospheric pressure. And if you get this very, very quickly, guess what? This is everything that is expected of us to note under this. I'll see you in the next lesson. We are going to take it a little what more further, and that's our what? Lesson 2. See you there. Bye-bye.